Okay, so grab your notebook, please. If you don't have your notebook out, grab that out. Okay, and we're going to talk about scientific notation today. Okay, and maybe, does anybody remember doing scientific notation in 6th grade? Maybe, maybe not. Okay, hopefully you'll find that this is actually kind of easy. Okay, so I want you to take a minute, write in your notebook, scientific notation. Okay, and scientific notation is just really a way to deal with really, really large or really, really small numbers. Okay, and typically things like scientists use it because they're dealing with really, really large or really, really small numbers. Okay, so there's a lot of this stuff that you don't have to write down. Okay, like this. Do not write all of this down. That's way too much to write, and it'll be online in the notes. The average quarter contains about, let's see, it's tens, hundreds, thousands, millions, billions, trillions, quadrillions, quintillion, 97 sextillion, 700 quintillion atoms. Okay, that's a lot. That's a really, really, really big number. Okay, now standard notation. Okay, when we talk about standard notation is when we take a number and we write it with all the zeros. Okay, I will say that is difficult to work with because it's really easy to forget a zero. Okay, scientific notation is a shorthand way of writing it. This over here, 9.77 times 10 to the 22nd power, that's scientific notation. Okay, it's a way to write a number so you don't have to worry about writing all the zeros. Okay, because zeros are really a big deal, right? If I had the number 1 million, which isn't even that big of a number, right? 1 million's big, but it's not so big we can't understand it, like 97 sextillion. 1 million, if I just forgot 1 0, I'm down to 100,000. Is that a big deal? Let's say you were an accountant for like this millionaire and he had $1 million and you accidentally forgot a zero and so told him he only had $100,000. That's like a $900,000 mistake. Oops. You might not have a job anymore. Okay? Or if you added an extra zero, so you didn't forget a zero, but you accidentally added an extra zero, now that person might think they have $10 million instead of 1 million. Is that a big deal? Absolutely. If I thought I had $10 million, I would probably spend money like I had $10 million. But in reality, I don't. So then I'd be in a lot of trouble because I spent way too much, okay? So we need to find a way or learn the way to be able to write these numbers so we don't have to worry about writing all the zeros. Okay? So, we're going to start by talking just about powers of 10. Okay? And I don't need you to write this in your notes or anything. I just want you to follow along. And maybe be willing to unmute yourself and answer some of these questions. When I ask you, what is 1 times 10 times 10 times 10? Okay? If we used a calculator, we could figure that out, but 1 times 10 times 10 times 10 is 1,000. Okay? And that is the same exact thing as 1 times 10 to the third power, because 10 to the third power is just 10 times 10 times 10. So this would be 1,000. Everybody agree with that? And we all know that 10 to the third power just means 10 times 10 times 10. So if I asked you to evaluate 2 times 10 times 10 times 10, what would that equal? Anybody?
2,000.
2,000, right? That's easy to do in your head. Okay, how about 3.4 times 10 times 10 times 10?
34,000?
Not 34,000. So here's where we have to be careful. 3.4 times 10 times 10 times 10 is 3,400. Okay? Now, ultimately, what I want you to get from this, okay, is what happens when we multiply a number by 10. If I take any number, 7 times 10 is 70.
It ends in 0.
Okay, so I heard somebody say it adds a 0. Kind of. Okay, what if I did 1 or 4.3 times 10? Well, 4.3 times 10 is 43. So did I add a 0? No. So what happens when I multiply a number by 10?
The first number stays the same.
It does. Okay, so let me give you another number. 5.74 times 10 is 57.4. Everybody see what's happening when I multiply a number by 10? Okay, somebody put it in the chat. You move the decimal over 1. Absolutely. When you multiply a number by 10, you just move the decimal. Okay, 4.3 times 10, I moved the decimal over 1. 5.74 times 10, I moved the decimal. I did the same here. 7 times 10, I moved the decimal, but the decimal right now is at the end. So when I moved it, I had to add a 0 in there. Okay, so when you multiply a number by 10, you're just moving the decimal over 1. Okay, you're moving it to the right. What do you think happens if you divide a number by 10? If I took 70 divided by 10, which is 7, what's happening then? Or I could do 43 divided by 10, which is 4.3. Or 7.6 divided by 10 is 0.76. So what happens when you divide by 10? Somebody said you're moving the decimal back 1. Absolutely, you move the decimal in the other direction. So when you multiply by 10, the decimal moves to the right. When you divide by 10, the decimal moves to the left. Okay? What if you multiply by 10 5 times? So if I said 7.8 times 10 to the 5th power, how many times do I have to move the decimal? And some of you are doing this, right? I'd have to move it 5 times because I'm multiplying by 10 5 times. So I have to take this 7.8 and move the decimal 5 times. And that leaves some blank spaces. So I need to fill in with zeros, and the answer is 780,000. Okay? So if you multiply by 10, however many times, you move the decimal that many places. Okay, so let's look at figuring out these. I want you to put some of these examples in your notes, okay? We want to be able to do this without a calculator because most of the time these numbers get way too big to do on a calculator. So I want you to let's start with just the first one. 25.7 times 10 to the 5th power. So write that in your notebook. 25.7 times 10 to the 5th power. Okay, and because we're multiplying by 10, 5 times, We want to move the decimal 5 places. So I'm going to take my 25.7 and I'm going to move it 5 places. 1, 2, 3, 4, 5. So now the decimal's at the end, and I have to fill in with some zeros. I need 4 zeros. So this is 257 with 4 zeros. 2,570,000. Okay, so we can do that all in our head by just moving the decimal. Okay, let's write this one down. 113 times 10 to the 7th power. How many times are we multiplying by 10? Right? 7 times, right? Because the exponent is 7. So how many places do we have to move the decimal? So lots of you are going 7. Yeah, we have to move the decimal 7 places. Where's the decimal? Where is the decimal in the number 113?
Behind 113.
Yeah, at the end. If you don't see the decimal, it's always at the end. So there's my decimal. I need to move it 7 places. 1, 2, 3, 4, 5, 6, 7. And that means I need 7 zeros in this case. So the number is 1,130,000,000. Okay. Okay, now this last one's a little bit different. It says 12 times 10 to the negative 5th power. Okay. If the exponent is negative, we're not multiplying by 10, but we're dividing by 10. Okay. So when we see a negative number right here, that means divide by 10. And what happens when we're dividing by 10? When we multiply, the decimal moves to the right. When we divide, the decimal moves to the left. Okay? So I need to take the number 12, which has a decimal at the end, and we need to move the decimal to the left 5 places. So if the exponent is negative, we're moving the other direction. So 1, 2, 3, 4, 5, which means I need zeros in front of the 12. So it's 0.00012. Okay, questions on that? Okay, so that's how we deal with multiplying or dividing by 10. Okay, now we're going to get to scientific notation. Okay, so there's a lot of writing on here. Don't write any of this down. Okay, scientific notation. Obviously, it has that name because it's mostly dealt with science, right? Scientists are sending a space shuttle to the moon or wherever. They're dealing with extremely large numbers, okay? You do not want to be the scientist responsible if you forget a 0 when you're sending somebody to the moon, okay? If you forgot a 0 and then you have to go to their family and say, oh, sorry, I'm not quite sure where they are because I forgot a 0 in my calculations. Okay, that would be bad. Also, really, really small numbers. When you look at things under a microscope, we use the microscope because they're so small that we can't see it without the microscope. We can't see it with our eyes. So then we oftentimes end up with lots of zeros in front of the number, okay? So we need to know how it's written, and it's very specific. Every scientist knows when they're using scientific notation, there is a specific way it's written, okay? So I'm going to give you some steps that you're going to write down. To go from standard form to scientific notation, write this in your notes. Standard form to scientific notation. Okay. Okay, so if we're going to go to scientific notation, the first step, step 1, is to determine the base. Okay, so just write the part down that I circled. Determine the base. That's your first step. Okay, the base, we're also going to write this down. The base must be a number from between 1 and 10. I'm going to change that, not from, I'm going to put between 1 and 10. It has to be a number between 1 and 10. Okay, so when I look at this number up here, 123 billion, I have to take my decimal and I have to move it. I have to move it so that I have a number between 1 and 10. Where would I put the decimal? Right now the decimal is here at the end. Where should I put the decimal to have a number between 1 and 10?
After the 1.
After the 1. Okay? So it's going to be 1.23. I'm only going to write down the numbers that are not zeros. All of these zeros at the end I'm not writing down. Okay, so I moved the decimal right there. Okay, then I want you to write down this. Step 2, multiply by a power of 10. Okay, so write that down. Step 2 is to multiply by a power of 10. Okay, so I'm going to put times, and we're just going to use an X for times. 10 to some power. Okay, now we have to decide what power that is. And to decide that, we're going to count how many places the decimal moved. Okay, the decimal started off at the end of the number right here, and it moved all the way to here. So we have to count, it moved 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 places. So it's 1.23 times 10 to the 11th power. Okay. Now it's positive 11 because we started with a really, really large number. If we would have started with a really, really small number, then it would have been negative 11. Okay, so let's try this a few more times, hopefully, so that we can get the hang of this. Okay, so we want to write this number in scientific notation. It's 27 with 12 zeros behind it. Okay, so write that number down in your notes, 27 with 12 zeros. And we have 2 steps. Step 1 is to get the base. Step 2 is multiply by a power of 10. Okay. Now remember, the base has to be between 1 and 10. So right now the decimal is back here. Where should I put the decimal so that we have a number between 1 and 10? Where should I move it to?
After the 2.
Right, after the 2. So we're going to move the decimal right here. So it's going to be 2.7 times 10 to some power. Okay, the power is how many places we moved the decimal. So we have to count. We moved the decimal 3, 6, 9, 12, 13 places. So 2.7 times 10 to the 13th power. Okay, be careful not to just count the zeros, but count all the places that you moved it. Okay, let's try another one. Here's a really, really small number, 0 point, and then there's 6 zeros and a 3. So 0.0000003. Okay, I need to move the decimal so that it gives me a base number that's between 1 and 10. Where should I move the decimal to? If I need a number between 1 and 10, where should the decimal go?
After the 3.
After the 3. I can't put it in front of the 3 because then it's not between 1 and 10. I have to put it after the 3. So we have 3 times 10. How many places did I move the decimal? And so this is really just a counting game. So it's 1, 2, 3, 4, 5, 6, 7 places. But because I started with a really, really small number, I have to make that exponent negative. It would be -7. If you start with a really large number, it's positive. A really small number, it's negative. So 3 times 10 to the -7th power. Okay, let's try another one. 0.00709. Okay, if I want to write this in scientific notation, where should I move the decimal to? Or what should my base number be?
7.
Not just 7. So we have to be careful because we have to write down everything except for if there's zeros in the front or at the end. Okay? So you're right to move it after the 7. I'm going to put the decimal right here. Okay? We can't put it after the 9 because otherwise we have the number 709. And remember, the number has to be between 1 and 10. Okay? So it's going to be 7.09. That's my base number because now it's between 1 and 10. Times 10. How many places did we move the decimal? We just moved it 3. Should it be negative or positive? Negative in this case, so 10 to the -3rd power. So 7.09 times 10 to the -3rd power. Okay, let's try one more. 109 million. The decimal right now is at the very end here. Where should I put the decimal so it's a number between 1 and 10? Okay, if I put so I had a couple of people say after the 9, if I put the decimal right there, would I have a number between 1 and 10? No, because I'd have 109, right? So I can't put it there. After the 1, now do I have a number between 1 and 10? Yes. So now I can write down 1.09. I don't have to write all the zeros at the end. That's the whole point of this, is to be able to get rid of them. 1.09 times 10, and we move the decimal 3, 6, 7, 8 places. And this time it's positive because we started with a really large number. So 1.09 times 10 to the 8th power. Questions there? Okay, that's the hard part of this. Going the other way is easy. If I ask you to write a number in standard form, this is easy. Okay, if I said write 3.45 times 10 to the 12th power in standard form, Standard form means writing it with all the zeros. Okay, so we look at how many times are we multiplying by 10? Well, we're multiplying by 10 12 times. So you just move the decimal 12 places. So we have 3.45. Move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places. So my final answer would be 3, 4, 5 with 10 zeros. Which would be 3,045,450 billion. Okay, you don't have to know how to say the number, you just have to know how to write the number. Okay, let's try another one, like 2 of them like that. So 3.7 times 10 to the 9th power. Okay, so if I have 3.7 times 10 to the 9th power, put this in your notes. I want to write that in standard form. That means I'm multiplying by 10 9 times. So I'm going to take my decimal. We have 3.7 and I'm going to move it 9 places. Since it's positive, we're going to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my final answer is 3, 7 with 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. So it would be 3,700,000,000. Okay. On letter B, the exponent's negative. What happens when the exponent is negative?
The opposite.
We move the other direction, okay? So we have 102. Right now the decimal's at the end. The exponent is a negative 5, so we have to move to the left 5. 1, 2, 3, 4, 5. So we get 0.00102. Okay, there's our answer. Questions there? Okay, so let me ask you this. If I gave you this number, let's see what you learned, okay? If I gave you 34.3 times 10 to the 7th power. Did I write that in scientific notation? Is that scientific notation? What do you think? Put thumbs up if you think yes. So I can see, if you have your video on, I can see you. Thumbs up if you think yes, thumbs down if you think no. And so all of you that have your thumbs down are correct. This is not scientific notation. Can somebody tell me what's wrong with this? Why is this not scientific notation? Anybody know? Go ahead, Brooke.
Because it's not, the base isn't a number between 1 and 10.
Right. Remember I said that this number right here has to be between 1 and 10, and it's not. So we could fix it. We could make it scientific notation by moving the decimal 1 more place. So it'd be 3.43, but then it would have to be 10 to the 8th power because we moved it 1 more place. Now it's scientific notation. Okay, so remember that base number always has to be between 1 and 10. Okay, questions there?